Now I'm going to today explain very important part in fluid law, that is boron family, group 13 elements. And so members are, this is boron, aluminium, gallium, indium and thallium. This is thallium. 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 This is indium. This is gallium. And this is, boron and aluminium. So these are the members. And children, I had explained on previous topic that there is the decrease in the character. Boron and aluminium, they are pure metals. This gallium, it is also metallic, but it is less metallic. Gallium, it melts on our palm. It is just like wax or butter. Gallium has melting point less than 30 degrees Celsius. Its melting point is 29.6 degrees Celsius. So it melts on our palm. Just like we take a small amount of butter, it will melt. So similarly, gallium melts. Indium, thallium, they are, much less metallic in nature. So this is about the basic point. Now I'll say first general electronic configuration. General electronic configuration. So general electronic configuration, or we say valence cell electronic configuration. So valence electronic configuration is, it is NS2 NP1. This is the valence cell electronic configuration or general electronic configuration. General means generalized form. So if you take the case of boron, so boron atomic number is 5, 1s2, 2s2 and 2p1. This is the K cell, this is the L cell. So thus we have like this. Similarly, in case of aluminium, aluminium 13, 1s2, 2s2, 2p6, 3s2 and 3p1. This is K, this is L, this is M. So this is also related to this. So we say that it is having the electronic configuration NS2N2. So we say that the 3 electrons are present. 3 electrons are present in the outermost cell. 3 electrons are present in the valence cell. So what is the meaning of this term is that they have valency of 3 plus. They are trivalent. Meaning is that the members are trivalent in nature. They have tendency to lose 3 electrons. They have tendency to lose the 3 electrons if they want to form the ionic compound. And so if they want to acquire the nearest noble gas configuration, very important point I am going to explain, that aluminium 13, 1s2, 2s2, 2p6, 3s2 and 3p1. Again I have written. So here it is. This is the valence cell. So in order to lose 3 electrons, it will lose 3 electrons, and then there will be combustion of aluminium 3 plus. So here it has 10 electrons, and as a result, this has become equal to neon. We say that the elements, they acquire nearest noble gas configuration. Elements acquire nearest noble gas configuration by the loss or by the gain of electrons. And so this is very much important point about the loss or gain of electrons. So here because they are metallic in nature. So they will lose 3 electrons from where? From the valence shell. And by the loss of 3 electrons, this aluminium will form the aluminium ion and it will acquire the nearest to less configuration, which is equivalent to nu. Now, this is the second very important part, atomic size and ionic size. Now, this is the very important part, and as a general trend, when we move from top to bottom, this group 13, boron is the first, and thallium is the last. We see like this. This is boron, aluminium, gallium, indium, and thallium. This is group 13. So boron is the smallest element in this group, and it is the largest. It is the largest element. But the question is why it is so. So children, it is because on moving from top to bottom in a group, there is the addition of new cell with every successive element. So reason is that on moving down the group, there is the addition of a new cell with succession, and thus the nucleus is unable to attract the electrons, strongly. So nucleus is unable to attract the electrons strongly. This I have written the reason behind this. Once again I am repeating, on moving from top to bottom in a group, there is addition of new cell. With succession means one after other. Just I will explain here. Thus nucleus is unable to attract the electrons strongly. Now see here, boron atomic number 5. Just I will take only 2 cases. So here 2 and 3. Here 2, 8 and 3. So here boron, there are 2 cells. 2 cells are KLL. Here 3. So 1 electron is added. 1 cell is added completely. It has 2 cells, it has 3. So it will have 4 cells. It will have 5 cells. It will have 6 cells. So as a result, there is the addition of new cell with every successive element in succession. And as a result, nucleus is unable to attract the electrons, and thus size keeps on increasing. So this is the explanation that why they are able to have this increasing atomic size, and so this happens with the ionic size also. Now children, I am going to explain next very important part, that is ionization enthalpy. Ionization enthalpy, or simply we call ionization energy. Ionization enthalpy or ionization energy. So first I am going to explain what is the meaning of ionization energy or ionization enthalpy. So ionization energy may be defined as the minimum amount of energy required by an isolated gaseous neutral atom to form the cation, and it is there in case of this. And we have this tendency. So it may be defined as the tendency tendency to lose the most loosely bonded electron from an isolated, this is very important, isolated neutral gaseous atoms to form a cation. This is the statement. This is the statement of ionization energy. Once again, I am repeating. It may be defined as the tendency to lose the most loosely. This is most loosely bonded electron from an isolated neutral gaseous atom to form a cation. It's called as ionization energy. So, as name indicates, ionization. So, the atom has to be ionized. The atom has to be ionized to form the cation. So, if we say like this, if there is atom A, this is isolated neutral gaseous atom, and we supply the energy. Here we supply the energy, ionization energy, IE, and let it loses some electron, and so there is the formation of cation. Now, here I have written isolated neutral gaseous atom. So, point is, what does it mean? So, children, it's very simple. Isolated, isolated means free from all the boundaries. Means there is no interaction. There is no interaction from any side. So, neutral, neutral, no charge. It is free, neutral, no charge. Gas and gas. So, the meaning is that ionization energy is a numerical value. It is measured in kilojoule per mole. It is measured in kilojoule per mole. So any atom, if there is atom A which is solid, so first it has to be given heat. It has to be given heat, and A has to be converted to liquid. Again it is heated, and A has to be converted into gas. So meaning is here we take in the gaseous form, and so why it is? Because in nature there are the different forms of elements. Some are in the liquid state, some are in the gaseous state, some are in the solid state. So the scientists have made this point that if it is a solid, in case of metal, it has to be converted into gas. If it is liquid, any element, it has to be converted into gas. So from the gaseous point of view, so any element, we want to determine its ionization enthalpy, it has to be converted into gaseous atom first. Now, I am going to explain the trends. Children, the trends in ionization enthalpy in the group 13. So, on moving down the group, value of ionization enthalpy, decreases. Value of ionization enthalpy decreases due to increase in size. So the value of ionization enthalpy decreases due to increase in size. The size increases. Why size increases? Size increases due to addition of a new cell with every successive element. So what we can say that boron will have highest, then aluminium, then gallium, then indium, and then helium. So this is the requirement of energy. This is size. Here the smallest size. Here the largest size. So what happens from this to this? The ionization enthalpy. What happens? Decreases. From boron to thallium, due to this the size. So here larger size, so minimum amount of energy required in case of thallium. And on moving from this to this, on this side, ionization enthalpy increases. So children, this is the trend in the ionization enthalpy, and this just I am explaining. This remains in all the elements, in all the groups. Now, next important part is the fourth. After ionization enthalpy, there is the electronegativity. There is the fourth is electronegativity. Fourth is electronegativity. So electronegativity, as name indicates, it is the tendency. It is the tendency to gain the electrons. Tendency to gain the electrons. So simply defined as the tendency to gain the electrons. It is the definition. Tendency to gain the electrons. Tendency to gain the electrons is called as electronegativity. So children know this, that on moving from top to bottom in any group, atomic size increases. So when atomic size increases, what happens? The tendency to gain the electrons decreases. So simply because size becomes larger, and in the previous point, the nucleus becomes weaker as size increases. So indirect meaning is that the nucleus becomes weaker. So electronegativity decreases in general. Why happened in general? Because there can be some regions. Why the electronegativity decreases. So there is variation. You will see in your higher classes. So this is general condition. So electronegativity decreases. Why? Because size is increasing from top to bottom, and so it decreases. Then coming to next point, metallic character. Next point is metallic character. So children, the general trend is, trends are very much important. Trends are very much important in the periodic table or all the groups. So in general, metallic character increases down the group. This is the general point. Why it is so? It is because of increase in atomic size. Reason is due to increase in atomic size. Due to increase in atomic size, the valence electrons are loosely bonded. Valence electrons are loosely bonded, and so metallic character increases. So what is the meaning of increase in metallic character? That is, That is, they lose electrons easily. And this is the metallic character. That metals have very strong tendency. Metals have very strong tendency to lose the electrons. And so this is very important. On the other hand, if we reverse it, so from bottom to top, metallic character decreases and non-metallic increases. This is the just opposite. This is the contrast. Once again, I'm repeating. In any group, not about the 13. I am talking to entire periodic table. Or moving from top to bottom, the metallic character increases. Increase in metallic character. And in opposite, when we move from bottom to top, metallic character decreases. Or we say non-metallic character increases. So this is the important trend in all the groups. Next point about the hydride. So children, I am going to explain very important points about the hydrides. Hydrides of Boron family. Now, hydrides are the binary compounds. If you say what are hydrides? So hydrides are binary compounds. Hydrides are binary compounds. Binary compounds formed. Binary compounds formed by reaction between or reaction with hydrogen. Reaction with hydrogen and concerned element. So you must have read in S law. So they form the hydrides like BH3, AlS3, GaS3, INH3, and thallium S3. All are called as trihydrides. They are basically trihydrides. They are trihydrides. One molecule, this is boron trihydride, aluminum trihydride, gallium trihydride, indium trihydride, and thallium trihydride. Now, very important part, they are formed by the reaction between the element and the hydrogen simply. But hydrides have some properties. We will see the properties of hydrides. So, first point is reducing character. First point is reducing character. So, children, reducing character increases down the group. Reducing character, they are able to reduce other elements. So, it increases down the group. It increases down the group. So, point is why it increases. So, simply children, size. Boron is the smallest size, so there is a very strong bond between boron and hydrogen. Here in case of thallium, the size is largest. So there is the increase in the reducing character. So boron will not lose the hydrogen easily, thallium will lose hydrogen easily. So what's the trend? Trend about this BH3 is the weakest, followed by AlS3, followed by GaS3, followed by INS3, and this thallium hydride. So it will be the weakest. It will be weakest reducing agent, and it will be the strongest reducing agent. So this depends on the size of the this molecule. It is basically related to the size of the molecule. Now, the second part is the thermal stability. This thermal stability, or simply we call stability. So it decreases down the group. It decreases down the group. Why it decreases down the group? Due to increase in atomic size. Atomic size increases, and so atomic size increases, so they undergo dissociation very quickly. They undergo dissociation very quickly, and so it is the point. They the dissociation. Then what is acidic character? Acidic character. Acidic character tendency to lose the electron. So it increases. It increases down the group. Why it increases down the group? Because the tendency to lose the hydrogen increases due to atomic size increase, and so this is very important part in the this hydrides, and this is very important part, and so this is significant for the hydrides.